Okay, so now we want to talk about what we call the center of mass frame. Remember that these two cars can be observed from any frame, okay? And as long as that frame is moving at a constant velocity, we can do our analysis with no problem, okay? So if we have the runner, we have velocities relative to the runner. We have the velocity of both cars relative to one car or the other. There's a very special frame that's really convenient for analyzing collisions, and that's the center of mass frame. Okay, now let's think about what we mean by center of mass. Let's say I've got two masses here, and they balance at this point. Now it should be clear then that this is the greater mass, this is the lesser mass. Now if this mass moves some distance and this mass moves some distance, for example, if this mass is moving faster than this mass, then it's going to move the greater distance. That could correspond to this situation where we have a greater speed here than we have here. That's going to result in a center of mass that's now at a different point. So if this is the positions of the two masses, then a short time later, these are the positions. The center of mass will have moved in this direction. The balancing point will have moved in this direction, and I'm using the word center of mass because the balancing point is the center of mass. Now I'm talking about an ideal situation here, a strong but massless platform on which these two masses balance. Okay. So again, the balancing point is the center of mass, and we can observe the collision from the center of mass system, from the center of mass, well, within the system of the center of mass. The moving center of mass is just like this rudder here, although this rudder is probably not moving along with the center of mass. If the rudder was moving at the right speed, then the rudder would be in the center of mass system. The rudder would be stationary in the center of mass system, and the velocities of the cars relative to the runner would be their velocities relative to the center of mass. Okay, the velocity of the center of mass, and I'm not going to prove this right now, I'm just giving you an introduction to some of the main ideas. It's not difficult to prove, but the velocity of the center of mass is constant as long as the forces are equal and opposite, and as long as these are the net forces acting within the system. Again, if there are extraneous forces, this doesn't hold strictly. If the extraneous forces are much less than these forces, it'll hold to a good approximation, at least for a short time. Okay, anyhow, so the velocity of center mass is constant as long as the net force is the force, net force on each car is the force exerted by the other car or the other object. Okay, well, that means that if you have an inelastic collision, the velocity of the center mass is the common velocity, the common after collision velocity. By common, I mean the after collision velocity that the two objects have in common after their collision. Since, by assumption, in this collision, the only forces are the equal and opposite forces, then the velocity of the center mass after collision has to equal the velocity of the center mass before collision, which is equal to the velocity of the center mass during the collision at all points. And since the after collision velocity is this, as we saw in a very recent clip, this is the velocity of the center of mass. So I can say that this V prime, the common velocity, the velocity of two stuck together objects after the collision, is equal to the velocity of the center of mass. Now, as it turns out, if you put this condition together with this condition, let's save that. I don't want to pause this. Let's just take this idea You have a center of mass that's basically the balancing point that you would have for the two objects. We don't actually have a balancing point for these cars, but if we did, it would be moving like this, center of mass, and would have the velocity that the cars would have in common were they to collide and stick together. Okay, so we're going to want to analyze an elastic collision from the perspective of the center of mass frame, and that's going to give us kind of a neat result.